Hello, today I'm looking at M3 International A-Level May 2016. This is question 5. So I have a vertical ladder is fixed to the wall in a harbour. On a particular day, the minimum depth of water in the harbour occurs at 0900 hours. The next time the water is at its minimum depth is 2115 hours on the same day. The bottom step of the ladder is 1 metre above the lowest level of the water and 9 metres below the highest level of water. The rise and fall of the water level can be modelled as simple harmonic motion, and the thickness of the step can be assumed to be negligible. So I need to find, for 7 marks, the speed in metres per hour at which the water level is moving when it reaches the bottom step of the ladder, and then the length of time on this day between the water reaching the bottom step of the ladder and the ladder being totally out of the water once more, for 4 marks. Okay, so first of all I'll try and draw a picture to understand what's happening. So I've got my harbour wall, I've got my ladder, and it said that the minimum level of water happens at this time and this time, and the bottom step is 1 metre above the lowest level of the water. So if that's where the bottom step of the ladder is, then the lowest level of the water is here, water flow, which happens at 0900 or 2115. Okay, and then it says the bottom step of the ladder is 1 metre, and the bottom step of the ladder is 9 metres below the highest level of the water. So this length is 1 metre, and from here up to wherever the highest level is, which I don't know, but let's draw it here, water high. That's 9 metres. So basically what they've told me is if that's the bottom and that's the top, then the equilibrium position will be somewhere in the middle. Well, in fact, exactly in the middle of 9 plus 1, which is 10. And so therefore I know that the amplitude is 5. And the fact that they told me that it takes 12 and a quarter hours to go from the bottom to the top and to the bottom again, that tells me that the time period is 12.25 hours. 25 because 15 minutes is a quarter of an hour. So from this I can deduce that omega will be 2 pi over t. So here I get that omega is 2 pi over 12 and a quarter. Now 12 and a quarter is 49 quarters. So the 49 ends up on the bottom, the 4 ends up on the top. So I get that omega is 8 pi over 49. Now that I've deduced A and omega from all of that information that they told me, let's try and focus on what they asked. So they said, find the speed in meters per hour at which the water level is moving when it reaches the bottom step of the ladder. Well, so basically I need a link between x and v, and I've got that with the equation v squared equals omega squared, open brackets, a squared minus x squared, where this is the displacement from the equilibrium position, this is the amplitude, and this is omega that we found there, and this is the velocity. So I'm looking for v, and I know omega is this, so I have 64 pi squared over 49 squared. The amplitude I know is 5, I work that out here, so I have 5 squared minus x squared. Now remember, x is the distance from the equilibrium position, so if we're talking about this level here, then that is a distance of 4, because I do 5 minus 1. Popping all of that into my calculator then, I get 5 squared minus 4 squared gives me 9, times 64 times pi squared divided by 49 squared. And so I get v squared is this. So therefore V will be the square root of that, and I get 1.5 or 1.54, and that is meters per hour. Why is that per hour? Because my period was measured in hours, and so any times that come out of this will be measured in hours. If I change that into seconds, then this would be in meters per second. Now part B. It says find the length of time on this day between the water reaching the bottom step of the ladder and the ladder being totally out of the water once more. So the time begins measured from here, and then after it's moved 1 meter, the ladder starts to become covered with, in the water. Then the water will go up to the highest level and then come back down here again. So basically what we want is a whole time period, but not this bit of time that it takes for it to go from this lowest level to here. Once and then twice when it comes down at the bottom again. So basically I want to find the time required is going to be the period minus 2 times t, where t is the amount of time it takes for the water to go from here to here. So if I use x equals a cos omega t, I'm using cos omega t rather than sin omega t because the simple harmonic motion starts here when t is 0. Cos of 0 is 1, and so I'll get that x is a. Okay, so basically I want to know when x is 4. Now I know a is 5 from the work that I previously did, and omega is 8 pi over 49t. So rearranging this, I get 4/5 will give me cos blah blah blah. So if I do inverse cosine of both sides, then I'll get 8 pi over 49t. So to get t, I multiply this by 49 and divide by 8 pi. So I get that t is 49 over 8 pi multiplied by inverse cosine of 4/5, and make sure your calculator is in radians for that. So we've got 49 over 8 pi multiplied by inverse cosine of 4/5, and that is the amount of time that I get there. So now the time required is, therefore time required is going to be 12.525, minus 2 times 1.254, this answer that I got here, 46. So I get 12.25 minus 2 times the answer, oh dear, whoops, oh poo, times the answer, no, oh it's because I'm pressing the wrong thing, right, okay, so I've got this, okay. Okay, so you should get 9.74 hours or 9.7. And let's just check if they said something specific. They just said the length of time on this day. So they didn't specify how that should be measured. So you can leave it like that as a decimal in terms of hours. Okay, so that last part of the question was worth 4 marks. So you've got 7 marks, 4 marks. So altogether 11 marks in that question. Okay, I hope you found this solution helpful. Do click like if you liked it, and good luck with your revision.